Today we're going to look at solving linear equations. By the end of this session, you'll be able to solve equations that involve brackets and algebraic fractions, and also be able to demonstrate that you can solve those equations clearly communicating your answers. So when we're looking at solving linear equations, linear equation is any variable raised only to the power of 1. There are no other variables that are re-raised to any other power. If a linear equation was graphed, it would be a straight line, a straight unbent line. It would, and that's why it's called a linear equation. They can also be represented in the form y equals mx plus c if they were rearranged. Linear equations can be solved by completing the same operation on both sides of the equal sign, gradually simplifying the equation. So we need to remember that an equation, both sides of the equals sign are equivalent, so it means we need to do exactly the same operation to both sides of the equation to be able to ensure that it is balanced and maintains the integrity of the equation. So our aim is to try and simplify in a number of steps so that we're reduced to just what the final variable is. So we need to look and ensure that the solution is communicated clearly. So we need to make sure that the steps that we include are enough to be able to communicate what process was followed by a student that's in your peer group. So if you give your a solution to another student, they should be able to say, yes, that's what they've done from this step to this step to this step to this step. It needs to be nice and clear. So strategies that you can use to solve an equation and make it simpler as you go and simplify it down include using inverse operations. For example, you've got 3x equals 6. You might think, well, that's 3 times x. The inverse operation of times is divide. Likewise, the inverse operation of plus is subtract. So those might be some strategies that you can use. So using those inverse operations. You can also look at collecting like terms. That will often simplify things. You can expand brackets out. Cancel common factors is often a very, very helpful way to do it. And when algebraic fractions are involved, if you multiply both sides by the lowest common denominator, then that can be a really helpful strategy to be able to simplify your equation down. So let's have a look at some examples and see how we go with those. So our first example, A, is 3 times 2 x plus 5 equals 4x. So there are a number of different ways that we can solve this equation. Probably the easiest way is going to be to expand the brackets first. So if we expand these brackets out, we get 6x plus 15 equals 4x. So has this step to this step been clear? Well, I've only done I've only completed one operation or one action. I've only expanded the brackets. That's allowed it to be pretty clear what I've done from step 1 to step 2 here. What I can then do is have a look at subtracting 4x from both sides. I can see that would remove the 4x from this side and would reduce it down and simplify it slightly. So if I were to do that, subtract 4x from both sides, I'll get 2x plus 15 equals 0 here. Now, having a look at simplifying this further, I could subtract 15 from both sides to make sure I'm separating out the variables and all of the other constants. So if I subtract both sides by 15, I'll get 2x equals negative 15, subtracting both sides by 15, and then I can look at dividing both sides by 2 and I'll get x equals negative 7.5. So I can express that as a decimal, or expressing that negative 15 over 2 as a fraction in its simplest form is also acceptable. Okay, so either of those answers would be fine. There are other ways to complete this equation. So you might want to divide both sides by 3 to start with. It would make it a little bit more challenging because you'd be having 4x divided by 3 to start with. It might involve a little bit more of toing and froing with algebraic fractions, which might be a little bit less direct of a method, but there are other ways to solve this. There's not one correct way to solve it. The way I've shown you is not the only correct way to solve it. But what is an excellent strategy for checking your answer, because you can check it in the exam or in any exam, in any situation where you're not exactly sure whether the answer is totally correct. You can substitute that value back into the original equation and see if the answer is true. So if we were to substitute this back in to our original equation, we could use a calculator to determine if 3 times 2 times negative 15 over 2, or negative 7.5, plus 5 is the same as 4 times negative 7.5. So doing that would be able to check whether you've got the correct answer or not. Let's have a look at B. So we've got B is equal to x plus 3 over 4 equals 2. So here, once again, a number of strategies that we can have a look at. We've got our algebraic fraction on one side. If we multiply by the lowest common multiple, or the lowest common denominator of both sides, then we can make sure that we can remove any algebraic fractions that we actually have there. So if I multiply both sides by 4, the denominator on the right-hand side of our equation is 1, so lowest common multiple of 1 is going to be whatever the other one is, 1 and any other value. So the lowest common multiple of 4 and 1 is just 4. Multiply both sides by 4, and I get x plus 3 equals 8. Here, so x plus 3 equals 8. Then I can subtract both sides by 3, subtract 3 from both sides rather, and I get x equals 5. Once again, we can check whether our answer is correct by substituting x equals 5 back into our original equation and seeing if it's true. So if I do that, 5 plus 3 divided by 4, yes, that's the same as 2. So we can check our answer there. Last example, example C here. A little bit more complex. 4x minus 2 over 3 is equal to 3x minus 1 over 2. Now, having a look at this equation, what I can do is I can multiply both sides by the lowest common denominator of our algebraic fractions. The lowest common denominator of algebraic fractions here is 6. If I multiply the left-hand side by 6, I'll be left with 6, and then in brackets, x minus 2 over 3. So I'll be left with 6, x minus 2 over 3. And if I multiply this one, I get 6, 3x minus 1 over 2. And you can see that if I've got the 6 and the 3, then the 6 and 3 will cancel to 2 over 1. 6 divided by 3 is 2. And I've got 6 over 2 on the other side, on the right-hand side, and that'll be 3 over 1. So what I'm left with is 4x minus 2 equals 3x minus 1. So you can see it's something that is not very mathematical. It's not got any mathematical basis, but you might hear it called cross multiplication. But what they're really doing is multiplying both sides by the lowest common denominator and then cancelling. Okay, so that's one step that's being done. Multiplying both sides by 6 and then cancelling the numerator and the denominator out. So we can then solve this very easily by expanding the brackets and then collecting like terms. So here, if I expand the brackets out on the left-hand side, I'll get 8x minus 4 equals 9x minus 3. I can then, let's have a look. What am I going to do? I'm going to subtract 8x from both sides and get negative 4 equals x minus 3. Then I'm going to add 3 to both sides. So I'll get negative 1 is equal to x. So it means our value for x is equal to negative 1. Okay, so once again, we can check our answer by substituting back in to the original equation and seeing if we get the same answer for both sides. So let's just recap the steps that we've completed here. So our first main step was multiplying by lowest common denominator on both sides and then cancelling. So and cancel, that's what we did in our first step. Then we expanded our brackets. Then we've simplified as we've gone down by collecting like terms, subtracting variables from both sides, subtracting and adding numbers to both sides.